3.6, solve radical equations. To solve a radical equation, follow these steps. Step 1 is to isolate the radical on one side of the equation. Step 2 is to raise each side of the equation to the same power to eliminate the radical. And you will end up with a linear, quadratic, or some other polynomial equation. Step 3 is to solve that polynomial equation. On example 1, our radicand is already isolated. There's nothing being multiplied to it out front. There's nothing behind it being added or subtracted. And so we're going to go right to step 2. Raise each side of the equation to the same power. We have a third root, and so I am going to cube this side, and I'm going to cube the second side. We know that the cubed root being raised to the third power undo each other, and we're left with just 2x plus 7, and then 3 cubed is 27. Solve the equation. As always in algebra, we know that we can check our solution if we're wanting to get that A or a better grade on a test, and I'm going to check. The cubed root of 2 times 10 plus 7, does that equal 3? The cubed root of 20 plus 7, and we know the cubed root of 27 is 3. Example 2, we need to isolate the radical. Well, where's the radical? Remember that x to the 2/3 is the same thing as the third root of x squared. And so we do have a radical here. It's just in its rational exponent form. So we need to isolate it. That means we need to get this x to the 2/3 by itself. We are going to divide both sides by 4. And we get x to the 2/3 equals 9. And now we are ready to get the exponent by itself. How can I undo x to the 2/3? I want an exponent that says x to the 1. What could I do? I could raise this side to what exponent? What exponent would give me a 1? I need my 3's to cancel and my 2. So I'm going to raise it to the 3/2 power. And then I see that my 3's will cancel, my 2's are canceling, I have an x. I'm going to change my base to 3 squared. And now I can see that 2 times 3/2 is just going to be 3 to the 3rd power. The 2's will cancel. X equals 3 cubed, so x equals 27. Check. 4 times 27 to the 2/3, does that equal 36? And again, there's so many different ways to go about doing this. You could change this into its radical form and take a look at it that way. However you want to do it is fine with me. I'm going to change 27 into 3 cubed and play the exponent game. Here, my 3's will cancel, and I'm left with 3 squared. And 4 times 9 does equal 36. Example 3, we see that our radical or our rational exponent is not by itself. Here's the radical, otherwise known as the rational exponent. And it's not by itself. It has something that's being subtracted on the outside. So I am going to add 1 to both sides to isolate that. I have x plus 2 raised to the 3/4, which now equals 8. And I am ready to undo the exponent of 3/4. If I multiply this, if I raise this to the 4/3, and I raise this to the 4/3, we're going to get those to cancel, and we're left with x plus 2 equals 8 to the 4/3. Or play that game of exponents and say 2 cubed raised to the 4/3. Our 3's will cancel. We have x plus 2 equals 2 to the 4th. Example 4. Now it's getting a little bit more involved. We don't just have one term over here. The radicand is isolated. And so I know step 2, I can raise each side to the same power. I'm going to raise this side to the second power, and I'm going to raise the left side to the second power. Remember that a plus b squared has a middle term. You have your a squared, and then 2 times a times b, and then you have b squared. So we have x squared, and then 2 times 1 is 2, times x is 2x, and then 1 squared is 1. And here we have a square that undoes the square root, and we're left with 7x plus 15. And we're ready to combine all of our x's on the same side of the equation. I'm going to subtract 7x, subtract 15. We have a degree 2, a quadratic. Do you know how to solve for a quadratic? All right. What we need to do is we need to check, because sometimes we have extraneous roots. Let's check. So we have 7 plus 1 equals the square root of 7 times 7 plus 15. We have 8 equals the square root of 49 plus 15. 64. And we get that 8 equals 8. So 7 is a solution. Now we need to check x equals -2. So -2 plus 1 equals the square root of 7 times -2 plus 15. So we get -1 equals -14 plus 15. And we see here that -1 does not equal 1. That means that -2 is an extraneous root. Our final answer is x equals 7. Solve the equation, check for extraneous solutions. Again, it's getting more difficult. I can't isolate the radical. If I shift the 1 to the other side, now it's with the other radicand. But what we can do is, it's a square root, so we're going to raise both sides to the second power. Here, this is the same thing as a plus b squared. Watch out for that middle term. We have a squared and then 2 times a times b plus b squared. So the first term is the square root times a square root gives us exactly what's underneath. And then we have 2 times 1 is 2 times the square root. 2 times the square root. And then 1 squared. Over here, the square undoes the square root times the square root, and we get 3 minus x. And we do have a radicand here that we need to isolate. We need to get everything away from it. All right, so we do have 2 plus 1, x plus 3 plus 2, square roots of x plus 2. I'm going to shift the x and the 3. And we have 2 square roots of x plus 2 equals negative 2x. Finish by undoing the multiplication that's here. Undo multiplying with dividing by 2. And we have the square root isolated. And we're ready to do that process again. Square both sides. And we get x plus 2 equals x squared. Combine all of your x's and solve. Check for extraneous roots. We have checking 2. 2 plus 2 is 4. The square root of 4 plus 1. And 3 minus 2 is 1, so the square root of 1. The square root of 4 is 2 plus 1. And 3 does not equal 1. So 2 can't be a solution. Let's check. X equals negative 1. That would be negative 1 plus 2, which is the square root of 1 plus 1 equals, watch out on the other side for those double negatives, 3 minus negative 1. We know that x equals negative 1 is a solution, and x equals 2 is extraneous. We could use a calculator method on this. Let's get our graphing calculators and see how to do this. Using the previous example, we're going to let y1 equal the left-hand side of the equation. The square root of x plus 2. Make sure that you arrow out from underneath the radicand using your arrow keys. And then plus 1. That's y1. And now y2 is going to be the right-hand side of the equation. So arrow down to y2. And we have the square root of 3 minus x. Graph. We are looking for where these two are intersecting. That would be where they're equal. We are trying to find out what x equals. So we would go to calculate, and we're looking for an intersection, number 5. It says, first curve, is y1 your first curve? Yes, it is. Enter. Second curve, is y2 your second curve? Yes, it is. Enter. Enter again. And we get x equals negative 1, 2. This means that x equals negative 1. The same answer that we got when we did all the algebra.